New, 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 new.
All right. Don't forget, we are shipping safe. We are shipping smart. We are shipping from New York City. The best comeback story during this time that I know of. So let's see what we're making this week.
We got a lot of stuff. Okay. So you got 2 SPI FRAM breakouts. These are pretty neat. Actually, someone emailed us and said, hey, check it out. There's new FRAM chips available from Fujitsu that are like really big. And I'm like, you're right, they're really big. We've had SPI and I2C FRAM, but they were like 32 kilobytes or something, which is okay, but we really wanted more. So we now have SPI FRAM with a logic level shifter, because these are 3-volt only devices, in both 2 megabit and 4 megabit, which is actually kind of, yeah, they look kind of the same. The 2 megabit is just a smaller chip, but they both fit on the same breakout. It's logic level shifted, and there's a regulator, so you can use it with 5 volts or
we can get this one.
3-volt logic and power.
What's the difference between the two?
One's chunky. See, this one's chunky, 4 megabit.
Yeah.
Svelte, 2 megabit. So why are these great? Well, FRAM allows you to store data in a non-volatile sense, which you write a byte. You've written a byte. They don't have wear leveling issues like SPI flash, so you can write each byte, I think, like 100 billion times or something like bonkers, like 10 to the 12. It's a huge number. You can write instantly, so it's much, much faster. You don't have to erase a page and then write a page. You can write each byte and you can write it instantly. So if you're doing data logging and you don't have like megabytes to data log, but you want to make sure that your data log is written instantly, it doesn't have to flush, and you can stream data to it much, much faster, again, than SPI flash, because you don't have to erase any pages. Just write the data as is, and we've got both Arduino and Python code to interact with these chips.
Okay, next up, this one tried to sneak in.
That's right, sneaky. This is a new little buck converter. You'll notice I have a couple buck converters. I'm designing some boards that have bucks in them, and so it's like, well, you know, I've got these chips here and I've kind of designed it, but I will make a breakout. So this is a very low cost buck converter. It doesn't have the high range that the NPM 3610 has. We put those in the store a couple weeks ago. Those can do 20 volts. This can only do like 5 volts, maybe 6 volts in, 3.3 volts out. It can do about 1.2 amps, which is really nice. It's very small, it's inexpensive. I think this is still pretty handy. You know, if you have a small circuit that was running on 3.3 volts, you need about an amp, and you've got, you know, maybe a LiPo, or you got a couple AAA or AA batteries, or you've got 5-volt USB, this will be a great little addition to your circuit, and you know, you'll be able to get much more current than a linear regulator for the size, and without the heat issues that you have with linear regulators.
All right, next up.
Next up, we have a new version of our RGB Matrix Featherwing, which people love. We had the M0 and M4 version, which was used for, as you may guess, our Feather M0s and M4s. But when we came out with the NRF52840, we were, you know, part of the deal is that you have to pick very special pins, and those pins were not the same on the NRF. So I kind of respun this board around a little bit to make it Feather NRF52840 compatible. So it works with both the Feather Express NRF52840 and the Feather Sense. You can assemble it in 2 ways. One way is you have like the socket on the top, so you can have the boards side by side and the RGB matrix plugs into the top. The other way to do it is where you solder it onto the bottom. There's a socket connector you put on the bottom, and then when you want, you can plug it into a board. So for example, let me just show this off. This is a Feather Sense here, so it's got all these sensors built in, and I've soldered up the wing so that it has these sockets on the bottom. So you see the feathers on top, which is nice. You can see all the sensors and the light sensors and the switches, and the LEDs are available. And then this plugs into the matrix, and then I've got this demo. So let me see if I can reset it. So this is my bring it down a little bit. This is a very big matrix. So I've got this LED sand demo from the Feather Sense, which has an accelerometer in it. It can, you know, measure tilt, and so it knows when I'm moving it, and the LEDs move with it kind of in a cool, fun way. So again,
That's
LEDs and then LED sand. So just ported this demo over. And what's nice is how clean the wiring is. Again, no jumpers, no breadboard. You plug it right in, and then you just have the power connect through, and then you can power it from a DC jack very easily. So it's a great addition, and you still have all the sensors here. You have the Bluetooth, and now we've got Arduino and CircuitPython code for driving these matrices now. So very easy way to make a glowy project.
All right, next up, let's go to...
Ooh, this is a cool sensor. So this is a new sensor that Brian Sedacious put together, and it took a couple weeks, but it was worth it. So this sensor is a multispectral sensor. It has 10 color sensors inside of it, like different wavelengths. You can see the wavelengths in the back: 415, 445, 480, 515, 555, 590, 630, 680, clear and near IR. So you've got 8 visible colors, 1 clear, which is kind of like general white overall lux, and then near IR. And it can measure these separately as individual bins, and that's kind of neat because you can do, it's like a very small, very basic spectrometer that works over I²C. It's very inexpensive considering what you're getting with it, and I think it can be really useful for science projects, or it's used for detecting the true color of lights or monitors to calibrate them. But I think it could be really cool for like some science or sensor projects. A very interesting new sensor.
All right, next up.
Okay, we finally got this in the store. We have the Sharp Memory Display, 2.7-inch Sharp Memory Display is finally in stock. We've carried the smaller version of this display, like 1.3-inch or 1.5-inch, but we saw the 2.7 inches had come down in cost somewhat to the point where it was like, oh, we can make a Breakout. So this is a very high resolution screen. It's 400 by 240 pixels. So you can see here the individual pixels. All the other demos I had to use kind of chunky, larger graphics because it was hard to see it because it's such like a fine pitch display. It runs off of both 3 and 5 volts. You actually need both voltages, I found out. So we put both a boost converter, a little switch cap converter, and a linear regulator. So you can use it with 3 volt or 5 volt logic. And then I ported Bad Apple to it, so I could show that.
Yeah, let's do it.
Okay, a second. I got to get my demo. Let's go to the overhead and show this off. So the only thing is the Bad Apple demo I took was 128 by. Oh no, my demo didn't work.
There you go.
Yeah. Oh wait, there you go. Ground wire disconnected. The only thing about this is I had to use a binary file that's 128 by 64. So everything looks really chunky because I scaled it up by 4 times. But what's really nice about this demo is it shows you both the refresh and the contrast and how it looks in real life with this silvery background and these black pixels. It's a very unique display. Extremely daylight readable. You do need to have light shining on it though. It doesn't have a backlight.
Yeah.
You can do that, and you can see it's actually a little shiny.
Yeah, look how sharp it is.
It's very sharp.
A sharp display.
It's called a Sharp display, and it is a Sharp display, even though it's the company. It's called Sharp. So a very high resolution display. One thing to watch out for. You really want to have a hardware SPI port to control it because there's a lot of pixels. And you need a chip with a lot of RAM because you have to buffer the whole display. So this is not going to run on an Uno or a Leonardo. You'll need at least like a Mega or like a Raspberry Pi or an M4 and M0 board in order to drive these beautiful displays. So very nice, also very thin.
Okay. Right along, next up.
Okay, next up, we've got some NeoPixel neon strip. I don't know, I kind of like these neon strips. I know we have a lot of them, but this one is RGBW. So it's a NeoPixel strip of encased silicone. So it's like flexible and very beautifully diffused. And one of the, and each LED inside not only has red, green, but also has white. So you can see this cool cool white color, as well as the the normal red, green, blue. So this is it runs off of 5 volts, which is really nice. This is looks like a normal RGBW NeoPixel. It's too washed out.
Yeah, that's a cool. This is the plastic that we use to better show.
It shows LEDs. I've solved the problem of how to use to show.
It's a nice
LEDs.
diffused rainbow.
Yeah, that's
Looks
very
cool.
nice. This is and this is just showing it's pure white, and then it goes back to the rainbow swirl. And what's nice about this is it's very flexible. You can twist and bend it. We see this a lot making cove lighting or like fake neon signs. So what I like about this is we had a couple versions that were like 12 volts, or they weren't RGBW. So we finally have one that's RGBW. I think this could be great for some kind of nifty art installations or lighting installations.
All right.
Okay.
Moving right along.
Moving right along. You got a lot to get through.
Yeah. There's this.
Okay, so we got this magnetic strip.
Magnetic strip.
This is such a weird thing. I don't know if anyone's going to want it, but I thought it was interesting. So what it is, it's a multi-pole magnetic strip, and this is used by CNC builders. And a lot like that current sensor I was talking about, what you do is you have a Hall effect sensor or a magnetometer, and you measure along the strip, and by measuring how the poles flip back and forth on the strip, you can determine what your position is and your speed and your direction. So it looks just like normal, like low-cost magnetic material. It's got that like kind of a dark gray look. This is magnet viewing film, so this lets you kind of see. It doesn't tell you the polarity, but it tells you where there's a magnetic field. So they put it over, you can see that there's alternating poles. So it goes north-south, et cetera, every 5 millimeters, and it's very precise. And so if you have a magnet, a Hall effect sensor that can detect north or south polarity, as it moves, even though these are 5 millimeter apart, it can measure the change in strength, which will be a sine wave, right? It won't be a perfect square wave, it'll be a sine wave. It can measure the speed and location along the strip. And this is much more flexible than an optical strip, and you don't have to have the delicate optical strip. This will of course survive much harsher environments because the magnetic sensor doesn't have to be physically touching or surrounding the strip. It's kind of interesting material. So we give it to you in a meter-long strip cut off for you. You can cut it with a powerful shear. It's got a 3M adhesive on the back. I'm not going to peel it off because it's extremely sticky, as I found out.
And you can splice it to the size you want.
You just cut it. Yeah, you just cut it into the size you want. You're not going to be like this is a meter long. You're not going to be making a CNC that's a meter long, probably. But I remember like when I was in school, there was always this problem of like you wanted to measure motion across a line, but you didn't want to get like a whole custom optical sensor. So I think even though this is not inexpensive, it is a really easy to use solution, right? You can use the same code that people have for everyday magnetic encoders, and you just use it on a linear strip rather than like a rotating sensor. So multi-pole magnetic strips. Somebody emailed us and said you should carry this, and I was like, well, it's kind of cool, and now we're carrying it.
All right. Next up.
Okay, now we've got a family of motors. So these are the first N20 motors that we're stocking. We wanted to hit it off with a bang. So these are, like we mentioned, encoder-enabled N20s. So they're the N20 size, which is kind of a standard size DC geared motor, and they've got a D shaft on the end. But what's really cool is it's not just a motor. It has an encoder built in, a magnetic encoder that has both direct, it has 2 outputs, and so you can tell both direction and speed. And these are really great little encoders. I've got a demo, you can show a little video. And we've got multiple gears. So I think we've got 1 to 50, 1 to 100, 1 to 150, and 1 to 300. So I kind of tried to pick, a range that people could use for their projects. And I'll plug this in. They have the same current. So all of them are this way. All of them are 6 volt nominal, but you can drive them at 4.5 or 5 volts. So I'm doing here 5 volts off of USB. And they all draw about 100 milliamps while rated, like running normally, and 200 milliamps while stalled. So not the most powerful motors, but I think it's a good trade-off of speed and size and cost. On the back, there's this little magnetic wheel. It has, I think, 14 poles, 7 pairs, and then you can power the motor with 2 wires through like any brushed DC motor driver, and then there's another 2 pins, 2 wires, one for power and ground for the logic levels. So it can be 3 or 5 volt logic, and then 2 more outputs that you can connect to, say, the interrupts of your microcontroller. And that's how this Featherwing setup is measuring the speed, RPM, and the direction. So you can see it knows it's going forward or backward. And then, there's a lot of robotics, especially as you start to try to drive straight and you realize that your motors aren't perfectly equivalent. Having an encoder lets you make sure that all the motors are matched up. You can also tell when you're stalling. You can tell which direction you're going. You can correct if somebody bumps into your robot or something. So I thought this was kind of nice because it's like an all-in-one motor solution. You don't need to use an encoder, but I think if you're paying for these, you should definitely hook up the encoder, at least one of them to tell the speed, 2 of them to tell the direction.
All right.
All right, so
Next,
N20 motors. Oh, and we have wheels for those as well. You need wheels. Magnetic feet. Okay, so these are just like these like magnetic feet. These come with RGB matrices, but our latest vendor of LED matrices, even though they've let us really reduce the cost of our LED matrices, would not include the magnetic feet, which is actually okay with. So now I sell them separately. They're a couple bucks, and if you want to mount your LED matrix on your fridge, for example, or on your multi-pole magnetic strip, pick these up. You get 4. You screw them onto the back. They got magnets.
Yeah. Okay. We now have the standalone AdaBox, the
That's
latest
right.
one. Get a clue.
Get a clue and all the clue accessories.
Yeah.
You get a pump and tubing and batteries and battery holder. You get a bonsai buckaroo. You get a glove, and you even get a KN95 mask. So you can build a ton of projects. What's interesting is usually we have more stuff in the box, but because the Qwiic is so integrated, it has 10 different sensors built into it. We have a lot of Qwiic projects, and it's on the cover of Make, so that you know that you can be inspired with Arduino or CircuitPython to get a clue and investigate the world around you.
Yeah. And the star of the show tonight, besides you, Lady Ada, and our community and our team at Adafruit, is
the MS8607 from TE. They make great sensors. This is a PHT sensor, also known as a pressure, humidity, and temperature sensor. Runs over I2C, so we put some STEMMA QT connectors on it. We're getting very close to 50 STEMMA QT sensors and boards, which is very exciting. Brian did the code for this one. You can program it in Arduino or CircuitPython or Python, so it works on a Raspberry Pi, an Arduino, a Qwiic if you wanted to add another sensor. And what's nice is that this is, previously there was only the Bosch sensors that had these integrated pressure and humidity sensing elements, and now we have a new contender, which I always like. I like to see more options. So here I've got a quick demo. I just have it plugged into a feather. So pressure, it's got the pressure, about 1,000 hectopascals. Humidity, it's kind of humid in here, 65%. Temperature, a nice 27 degrees. If I breathe on it, I can make the humidity go up, temperature goes up a little bit, and if I put my hand over the sensor, I can make the pressure go up a little bit. So these can be used as altimeters. It's actually a little bit more precise than the digits I'm showing. There's more digits I didn't print out because it wouldn't fit on the screen. We can use it as an altimeter. You can use it as weather sensing. You can use it for any kind of environmental or plant monitoring. So a lot of options. I like pressure, humidity, and temperature. It gives you a really good sense of what's going on in the enclosure or the greenhouse or your factory or what the weather's going to be like. So combine all together, it's a nice environmental sensor from TE.
all right. And that is